You know, artificial intelligence is doing some pretty wild stuff these days. It can write poetry, it can compose entire songs, and it can create these absolutely stunning pieces of art. It feels like it's changing everything. But there's this weird paradox, this really interesting puzzle at the heart of it all that takes us, believe it or not, right back to middle school.
And that's the big question for today. How is it possible that some of the most powerful AI models on the entire planet, models that have basically read the whole internet, can get totally tripped up by a geometry problem you'd find in an 8th grade textbook? Well, the answer reveals this really fundamental flaw in how we've been teaching AI, and it also points to a brilliant new way to fix it. All right, let's get into it.
So first things first, we've got to diagnose the problem. What is it about these diagrams and equations that just completely breaks an AI's brain? Turns out, it's not really about the math itself. It's all about the reasoning.
To really get it, you have to look at how these AIs learn. They learn from data, which are basically their textbooks. And this table, it shows that the textbooks we've been giving them are not very good. Just look at all those dashes for the other datasets. They're missing deep knowledge, they're missing principles. But then, look at that last row from MathBook. It maps out 491 core knowledge points. It's a real structured curriculum, not just a random pile of examples.
So, yeah, the problem really boils down to 3 big issues. First, their textbooks are incomplete, just full of massive gaps in knowledge. Second, the worksheets we give them are all wrong. The difficulty levels are based on what's hard for us, for humans, which is not at all the same as what's hard for an AI. And third, the AIs have learned to be amazing students at cramming for the test. They're trained to memorize answers, not to actually reason their way through a new problem they've never seen before.
Okay, so how in the world do you fix a problem like that? You don't just go looking for a better textbook. No, you have to build the ultimate textbook from the ground up.
And it all started with this number, 491. That's how many core knowledge points these researchers figured out were absolutely essential for geometry. They mapped out everything, from the basic definition of a line all the way to super complex theorems, creating this foundational skeleton for a brand new AI curriculum.
But they didn't stop there. Oh no, they got way more detailed. From those core concepts, they then mapped out 1,819 fundamental principles. These are all the individual rules, the specific formulas, and the definitions that make the whole thing work.
And when you put it all together, you get what they call the MathBook Knowledge System. And trust me, it's not just another data set. It's a complete 5-level map of mathematical knowledge. The best way to think about it is like the most detailed, perfectly organized syllabus ever created, but it was designed from day one specifically to teach a machine how to think.
But look, having a great textbook is only half the battle, right? The AI also needs a much smarter way to actually practice and study what it's learning. So to do this, the researchers created 2 custom-made workbooks. The first one, MathBook-Standard, is all about being flexible. It uses these clever tricks like showing the same problem with multiple different images so the AI can't just cheat by memorizing the picture. Then there's MathBook-Pro. This one is like a personal trainer, systematically ramping up the difficulty to build the AI's reasoning muscles.
So, how do they make the problems harder? Well, the first way is pretty simple. Just add more steps. They'll take a problem that maybe needs 3 logical steps to solve and expand it into a new one that needs 6 or 7 or even more.
The second dimension is visual complexity. This is where they start to get mean. They just clutter up the diagram with a bunch of extra lines and shapes that have nothing to do with the answer. This forces the AI to learn how to focus, how to find the signal in the noise, which is a huge part of how we humans reason visually.
And the last dimension is all about context. This is the classic word problem. They take the core math and wrap it inside a complicated real-world story. The AI has to learn to read the whole paragraph, understand the language, and pull out the simple geometry puzzle that's hidden inside.
So we've got the perfect textbook and a custom set of workbooks that get harder over time. The last piece of this puzzle is the teacher, a completely new way to train the AI.
This new teaching method happens in 2 stages. Think of stage 1, the cold start part, as just orientation. The AI is learning the basic language of the math book, how to show its work, that kind of thing. But stage 2, progressive alignment, that's where the real learning kicks in. It's basically like a video game. The AI tries to solve problems to level up. But, and this is the genius part, if it gets one wrong, a dynamic scheduler acts like a personal tutor. It steps in and says, whoa, hold on, let's try this simpler problem first to patch that knowledge gap.
and only then does it let the AI try the harder problem again.
Okay, so the system is built. The AI has gone through school. But did any of it actually work? Let's take a look at the final exam results.
The results are, well, they're pretty staggering. As you can see here, the new model, MathBook 7b, hit an average of 48.7% across all the standard tests. That's a jump of over 5% from the model it was based on. In the world of AI, an improvement that big is a massive win. But here's the part that might be the most incredible thing of all. It got that huge performance boost using only about 9,800 training examples. That's an incredibly small amount of data. It just proves that a smarter, more structured curriculum is way more powerful than just throwing mountains of random data at a model. It's all about quality, not quantity.
And this table is where you can really see the difference in how it learned. This shows how different models do as the problems get harder. Notice that as you add more reasoning steps, most models just start to fall apart. But look at the last row. On the absolute hardest problems, the MathBook model is actually scoring higher than the much larger GPT-4o. It's more resilient because it was actually taught how to reason, not just to recognize patterns.
So this is clearly about so much more than just solving for x in a triangle. This research has some really profound implications for the entire future of artificial intelligence. So here are the big takeaways. First, if you want to teach an AI something complex, you need a structured, comprehensive knowledge system, a real curriculum. Second, we have to start designing challenges from the AI's perspective, not just our own. And maybe most importantly, the goal has to be teaching AIs how to reason, not just how to memorize. This whole approach isn't just for math. It could be the blueprint for teaching AI complex reasoning in almost any field you can think of. Which leaves us with one last, really fascinating question. If we can teach an AI to genuinely reason its way through a visual geometry problem, something that's been a major roadblock in AI for years, what are the new limits? What can't it eventually learn to do?